Hello everyone, my name is Jingya. I come from Eindhoven University from the Netherlands. Today I'm very glad to be here and present our latest study. And now let's go turning our book into a game. I remembered when I was a kid, I always had a lot of homework, but I lost my attention very easily and just wanted to play even for a while. Today's kids are born with digital medium. They lost interest in the schoolwork or textbook. With serious games could improve their learning motivation. However, with these games, children will close their book and go into the digital world. What if we want to make the book itself more fun? Imagine this scenario. When a kid is doing homework on the book and starts losing concentration, and suddenly an animal pops up on the book. And the children can interact with the animal directly by moving the book. And the animal can ask some questions related to the book page, and the kid can get immediate feedback from the animal. This combination of physical book and the fun of digital game could improve children's learning motivation and attract them back to the book. And this is happening with AR series games. In our study, we aim to create a better understanding of how to design AR series game to offer children a more playful and fun learning experience. We applied self-determination theory as the fundamental framework. In the beginning of this study, we applied a co-design session together with children to better understand them and generate some design concepts. Based on the insights collected from the co-design sessions, we developed our base game prototype. So in this game, children use their mobile phones to scan the book to find out some virtual animals. They can interact with the animal, give the animal some food, and solve some math problems with the animals. We conducted a user study comparing this AR game with traditional paper exercise. Our result showed that AR game was considered more fun than the paper exercise, and there was no difference between the correctness of answering the question between these two versions. Well, this is just the beginning of this story. Similar to some other existing AR games, our base game applies the screen touch interaction as the input, and we use non-AR specific element to show some information such as the game progress. Well, we are thinking, since we are making an AR game, how can we make the interaction more intuitive, and how can we capitalize on the AR affordance to create a more immersive game world for children? So take a step further. We explore the intuitive interaction between the player and the book, and also we created a 3D progress map to show the progress. Now let's check out the new game together. So iterated from the base game, the main idea of the new game is that there is an exercise on the book page, and there are different answers popping up all over the book. The goal is to guide the animal to find the correct answer of the exercise. The left side is the screen touch interaction. Similar to the base game, the kid touches on the screen to guide the animal to the target answer. While on the right side is the tangible interaction. We turn the book itself into the interface with which to control the game. And there are two main actions, turning and lifting. With the turning action, kids turn the page around to navigate the direction of the animal. And by lifting the paper, kids can control the speed of the animal. If the kids lift the paper with certain angle, the animal will speed up. Similarly, if lifting from the opposite side, its moving speed will slow down until it stops. It's like an animal is climbing or sliding in the real world. So by comparing these two interactions, we are curious to find out to what extent children want to make effort in playing the game. Regarding to the feedback type, in the left side, after the animal finds the correct answer, kids will get immediate feedback on the top right corner on the screen. While with the 3D progress map, after the animal finds the correct answer, kids can collect the animal on the map. If the answer is correct, they can see the animal, and if the answer is not correct, they can't find the animal anywhere on the map. They can check the map anytime during the game, and at the end they can see how many exercises they have answered correctly by checking the number of the animals on the map. By comparing these two versions, we aim to find out the impact of an AR-enabled paradigms on the learning experience. We conduct a study with 32 children from the Netherlands aged 7 and 8 years old. We adapted questions from PENS and IMA questionnaire. We also observed their behaviors during the play, and we conducted an interview after the play. I don't know if you ever have experience playing or doing experience with this age group. Also, as the previous presenter just said, it is quite difficult because these kids are really sweet and they really want to make us happy. So they tend to select the highest ratings in the questionnaires. And sometimes they have difficulties understand the written emotions. Therefore, we also developed animated scales to help children to select more nuanced answers. We want to make children feel that there are other kids who are also expressing their opinions, and it is okay to have different opinions with the statement. We also want to attract children's attention more with these colorful and visually expressive characters than just on the paper. The animated scales include different characters with different gender and different appearance. Children select one character during the entire questionnaire. These expressions and movements were recorded by the acting of 2 professional actors. We also did some pilot study with these scales, but I don't want to keep you from lunch, so if you are interested, I can talk to you later. So now let's move on to the findings. Overall, our result shows that there are no significant difference between the 2 examined interaction types in terms of perceived competence, autonomy, and the enjoyment level. Regarding to the difference between the 2 feedback types, our data indicate that when receiving feedback through progress map, children significantly perceived more competence and autonomy, and they reported significant stronger feelings of enjoyment. Based on the findings, we generated some insights for AR series game design. First, our data showed that for series AR game, a simple screen touch interaction might already be sufficient. However, we see the potentials in applying tangible interactions when designing AR. There should be a video. Yeah. Although the tangible interaction requires more effort from children, they were not demotivated in using it. Instead, according to the interview, children found it interesting and more fun. We also observed that children enjoyed exploring and practicing the controls of the tangible interface. Therefore, using this physical book to control the game can be applied as a solution with which children can make meaningful actions and understand the direct response towards their actions. Regarding to the feedback types, the proposed progress map can be inserted into different books and can be generalized to different game stories, engaging children to interact with the book more. Therefore, when designed for motivating and immersive experience for children, we suggest designers to utilize the special affordance of AR to create stories or play spaces. They can integrate the virtual game elements more in spatial settings and combine them with the real world to gamify the learning environment. We are aware of the limitation in our studies. For example, we used the new animated scales, and we didn't measure the learning performance in the current study. And we are aware of these limitations, and will focus on them, address them more in the future, and we can carry out further systematic research. In conclusion, in this study, we examined the novel interactions and the representation paradigms that AR offers to better understand how they can influence children's learning experience and how to take advantage of them effectively. We think AR games can have strong motivational power to engage children in learning. By doing this research, we seek to build a systematic understanding of the design space of serious AR games and the ways in which it can improve learning motivation for children in the future. That's it. Thank you.
We do still have time for a few questions. So there in the middle. Yeah, mic is coming from your left. Okay.
Adrian Schneider from Queen's University in Canada.
Hi.
And I'm wondering, in the earlier study where the animals popped up when it was determined that the children were distracted, how did you decide when they were distracted? Because obviously you didn't want to distract them by animals if they were working really well.
Oh, you mean the beginning of the video I showed?
Yeah.
Yes, that's the story, the beginning of my story, but it's not the beginning of the study. It's the beginning of the study is the co-design session, and then we move to the animal pop-up from the book. And the distraction part, I mean, you know that children have a short concentration, and they always want to do something else when they study. So what we want to do is to create the book as a game. So when they open the book, the game already starts. So they answer some questions, and they can go into the game and see some feedback and see some reflections, and then maybe they will be more motivated to study with the book more. So I don't know when they will be distracted, but I'm sure they will be distracted at some point. Yeah, thanks.
There was another question at the other side of the room. Yeah. Here in the middle. Yeah.
Thanks. Catherine Gerling, KU Leuven. I have a really nitpicky technical question, I'm sorry. On the scale that you showed with the animated faces,
yeah.
I think it's really nice, but I'm wondering whether the negative point actually represents a no from a child of that age. How did you test the validity of the animations that you chose?
Sorry, I didn't get the question.
With your scales, you have different visualizations of how the person feels about the options that you offer.
Mm-hmm.
Did you check if the no visualization that you chose actually represents a no of the strength that you would have on a Likert scale? I can also ask you over lunch if I'm being unclear here, sorry.
Actually, this is the original scale is a 7 Likert scale, and we found children have this difficulty to understand the bipolar scale, so we changed it to the unipolar scale. So each question is it's a positive one; they can strongly agree with it, or agree, slightly agree. And there's a negative question; they can also strongly agree and agree, slightly agree. So. Maybe we can talk later.
Yeah,
I didn't really get.
Thank you.
Sorry.
Okay, I think it's about time. It's 12:30. So thanks again.